Swayam Prabha. Digital India. Educated India.
Good morning. Welcome back to the course Product Design and Manufacturing, wherein we are trying to learn the systematic procedure to obtain a final product from the very basic thing, from the idea generation only. So till now what we have covered is we have gone through basics of manufacturing, the systematic procedure for product development and manufacturing, also value engineering, quality function deployment, which is a technique to translate the customer needs into the manufacturer's documents. So in this module I will cover rapid prototyping, which is a technique to quickly produce the product or maybe the model. So what is a prototype? Prototype is an early sample or model that is used to test a concept or process or to act as a thing to be replicated or learned from. This prototype can be a computer program, prototype can be a physical product. We are more concerned with physical product here. We will try to develop a physical model of the product which we have designed, and we have made it to pass through various stages, various analyses, and finally we are ready with a CAD model. Now after that we will like to have a physical product to see how does the product look like, the physical product in my hand. For example, to produce a prototype of this product means to have physically all these shapes, contours, and to have this pen in my hand. So this is rapid prototyping. So in this lecture I will try to give some introduction to rapid prototyping, then we will see what is additive manufacturing. Rapid prototyping is now also known as additive manufacturing. Why it is so called? We will see. Rapid prototyping, some history on this, topography, photosculpture was a few techniques which were used in early 19th century. So we will see what are these things. Then we will see that rapid prototyping is an integral part of concurrent engineering. Concurrent engineering is thinking about the manufacturing during the design and the previous steps only. Now then we will go through the geometrical modeling techniques. These techniques are maybe wireframe modeling, then we have surface modeling, and solid modeling. Then we will see how does the information flow in rapid prototyping. This is actually rapid prototyping process, or better to call it a rapid prototyping procedure. So what is rapid prototyping? The process of rapidly creating a system or part representation. This is known as rapid prototyping. Rapid prototyping is used in a variety of industries to describe a process for rapidly creating a system or part. Before the final release, this is before the final release of product, or before commercialization. So what manufacturing concerns are interested in, they always would need to test their product before making it to go to final user. They would like to check that what is the feedback. They will first manufacture a few initial product, few early samples. They will like to give it to some internal customers. For example, I have been in Hero Cycles. For what they do, they first produce the bicycles, the initial models, and make the internal customers, the customers who are within their factory, they use the cycles for few days and they give the feedback, and that is why this rapid prototyping is also required, though the bicycles are not produced by rapid prototyping, but here rapid prototyping is required because we need to produce the product very quickly. It is said in manufacturing, in industry, if you snooze, you lose. So there needs to be some agile ways, some fast ways to produce a product to have the physical form that is even sometimes workable. So the output of this rapid prototyping is a prototype or a model in our case. We are not talking about any software prototype, but a physical model here. Physical model or a sample. This model is sometimes a working model as well. For instance, if I say the physical model of a pen, the pen model, the body can be something working in which the filler can be put in. So in case of in certain models, for example, the physical model of a car carburetor needs to be, the material has to be one, that material has to be aluminum. So this model can be a working model, or maybe if it is not working, at least we can have the feel of the shape and contours of the thing. In some cases, the model can also be a working model if it can take a load. For example, in case of this pen outer body can be a working model because the inner components can be put in. But when this is actually a stylus, if I talk about a pen, this inner refill, the ink cannot be generated here, the outer body can be a physical prototype here. That is working, in which this refill can be put in. So this prototype or model, the more emphasis here is on creating something quickly, and the output is a prototype from which the further models and eventually final product will be derived. The final product is derived from here, is derived from this prototype. In a product development context, the term rapid prototyping was used widely to describe technologies which created physical prototypes directly from digital data. So this allows users to test the product and provide feedback as well. Users of rapid prototyping technology have come to realize that this term is inadequate. So I'll come with some other thing, additive manufacturing. So why do they think that this term rapid prototyping term is not very adequate? We'll see. So the most recent applications of technology, that is the improvement in the quality of the output from the rapid prototyping machines, have meant that there is a much closer link to final product. For example, if I have my rapid prototyping product and this is my final pen, so it has a very close link, right? So the users or the manufacturers here think of why not to use this technique for final manufacturing. As we know, prototype is something that is the early product or the initial product. The final manufacturing, when is done through initially called rapid prototyping process, is called as additive manufacturing. As the additive approach is used in rapid prototyping, some material is being added, being deposited here. So this is known as additive manufacturing here. So many parts are in fact now directly manufactured in these machines. So it is not possible for us to label the term as prototype. So it is better to call it a product, that is additive manufacturing product. Now this American Society consensus standards now use the term additive manufacturing. However, there is still a conflict to use this term, but it is widely accepted. And even some of the journals, rapid prototyping journal is now known as additive manufacturing journal. The journal names are also renamed. The recently formed technical committee has named this thing. Now next, I would like to discuss how quick is additive manufacturing. Additive manufacturing, the basic principle of this technology is that a model that is initially generated using three-dimensional computer aided design, we call it 3D CAD model, this can be fabricated directly. Directly from the CAD model. This is the principle of additive manufacturing. Without any need of process planning, there is no need of process planning here. So it looks like that because this time consuming thing is missing, so this should be a quick process. So although this is not that simple in its first as it sounds here, the additive manufacturing technology certainly significantly simplifies the process of producing complex 3D objects directly from CAD data, but other manufacturing processes require a careful and detailed analysis of the part geometry to determine things like the order in which the features can be fabricated, the features of a product. For example, if I take the example of the pen only, pen has various components here. It has a clip, it has a click button, it has a refill inside. Now the part has various features. See, the contour is changing here. The contour is very much same through this. So this is one part, this is second part, this is third part, then the clip has to be there. What material would it be? Has it to be a metallic pen. In case of additive manufacturing, we only can have the materials for which powders or for which the liquid material is liquid raw material is available. So to decide these features is also a little complex thing. So what tools and processes must be required? Tools and processes for this one, and what are additional fixtures that are required? Additional fixtures to complete the part. So this is a little pitfall of additive manufacturing. So it is not that quick as it looked like, that it would go directly from 3D CAD model to fabricate directly. However, in 3D CAD model only, it takes a little time. Taking into consideration the manufacturing process. If this manufacturing process is traditional, then CAD model can be, the time could be less. If this manufacturing process is additive, then within this CAD model only, these things are taken into consideration, the features. AM, additive manufacturing, fabrication, that is the product features. So additive manufacturing needs some basic dimensional details and a small amount of understanding on how the additive manufacturing machine would work and the materials that are used. So the key to how additive manufacturing works is that the parts are made by adding material in layers. So when, for example, this mobile body, I take an example of a mobile body, this mobile body is to be manufactured using the additive manufacturing process. So in this case, additive manufacturing is always done in layers, and for layers the thickness is finite. The layer thickness would be very finite. We have layers here, we have a hollow space here for the screen. I am talking about the all model of the mobile, not the smartphones here. So this is just the outer cover of the mobile. So this is made in layers. So this layer has finite thickness, and the thinner the layer is, the closer is the final product to the original. That is, I would say layer thickness is inversely proportional to the accuracy, I would say, accuracy of final. Most of the additive, commercialized additive manufacturing machines used a layer based approach. So a layer based approach is used. It is layer by layer the product is manufactured. If I talk about this pen body, these layers would form my final product. This is a separate thing. Clip is made in separate layers here. So this will constitute my pen body. So if we are talking just about prototype, just the pen body that is not a workable, that is not a working model, then we can make it in one go. But if we think of to put a separate clip and separate click here, click button here, then this has to be made in parts. So the more complex the product is, the more is the number of components, more is the number of parts that is to be made in rapid prototyping, in additive manufacturing better I would say here. So in this case, this would be made separate. This is part 1, part 2 and part 3. These will be made separate, then would be assembled. The major ways these machines, rapid prototyping processes differ is, number 1, the materials that can be used, number 2, how the layers can be created, number 3, how the layers are bonded to each other. Number 1, the material, number 2, how the layers are created, and number 3, how the layers are bonded to each other. So in the next lecture, we will discuss various kinds of additive manufacturing or rapid prototyping processes, which are maybe common processes, stereolithography, laminated process, and some other processes. In those cases, we will see that what are the specific pros and cons of these specific processes here. So these differences determine the factors like accuracy of the final product. Now the factors that are dependent is, number 1 is accuracy of final product, then maybe material properties, when we talk about material properties, we can also say mechanical properties. Now, this kind of machine, the factors, the parameters that define the machine and the kind of the final product required, these further determine the process parameters, that is how quickly the product can be manufactured or how much post processing is required. The size of the product, it determines what is the size of the machine that is required. Cost is also one of the consideration. I would say the overall cost. Overall cost of machine, then process. As we have gone through the cost components, the final cost of the product is, or I would say the factory cost is the cost of the material cost plus operation cost plus labor cost plus factory overhead. So, this material cost is important here, material cost, the kind of material which we are using here. The operation cost is the cost of the process. Operation cost would also maybe include the cost of the machine, though it is an initial investment, but the final product which are made from these expensive machines are also sometimes costly, like they are sold at some higher price. So, then labor cost, what is the labor required? In this case, in case of automated system, the operation cost is higher. In case of manual system, the labor cost is higher. Then factory overheads are also there. So, this would determine my cost of the final product, final cost. Okay. So, let me compare additive manufacturing with traditional manufacturing here. So, this is one thing I would put it in this rubric here, in which I will call this first step is product design and development. Then we have manufacturing here. Finally, we will get an end product. Now, in case of traditional, that is non-additive manufacturing processes, this design is traditional, though CAD models, all those things are used here, but additive manufacturing consideration is not taken into account. So, this manufacturing is also traditional. This traditional does not mean the conventional machine. This traditional may be CNC machines, NC machines or conventional machines. Okay. Then we would have an end product that we have, that we could say product that is made from traditional processes. Now, in case of rapid prototyping thing, so what do you say in rapid prototyping? What is product design and development? So product design and development is a rapid process here, because we'll have a prototype in our hand. That would be a faster process here. And if I say manufacturing is traditional here, this end product here is not very much traditional, but a better one. Better in a way that is brought faster to market, quick to market. Then it is sometimes because the R&D, that is the product design development time, is lesser here, it is sometimes, or most of the time I would say, it is a cheaper product. It is of not cheaper, is less cost, but it is still limited to this traditional manufacturing processes. In case of, I would say, additive manufacturing, I would also include digital manufacturing here as well. Though I was going to put this is in a 4th step, but I will try now here put it in a, divide into 3 categories only, 1, 2 and 3. In this case, this one is rapid and this one is additive manufacturing. That is, the manufacturing of product is also, this kind of products are brought very fast to market. But only the limitation is the limitations of the additive manufacturing applications. Limitation, or I would say limited to additive manufacturing applications, because not all the products can be manufactured using additive manufacturing. So this is how we can compare the traditional process, both the things are traditional, rapid prototyping, in which only product design and development is rapid, and the manufacturing is traditional, and additive manufacturing, in which both the things are additive. So in the current course, we are more interested towards this thing, rapid prototyping. We will only discuss how the rapid prototype is produced. So I have just discussed additive manufacturing because you will definitely come to this term. When you talk about rapid prototyping, people will talk to you that what is additive manufacturing, how does additive manufacturing differ from rapid prototyping. These things would always come into account whenever you are in the interviews, in the job interviews, or you are in manufacturing. These things would also come into account. But that is why I have discussed this thing. So in the domain of this course, we will just discuss the rapid process to produce our initial or early sample, early model here. So little more information on additive manufacturing. Okay, so revitalizing again, additive manufacturing, in this the parts are made by adding materials in layer. The thinner the layer is, the more closer is the part to the final product that is required. The machines, most of the additive manufacturing machines used a layer based approach. We will discuss various kind of processes in the next session. The factors that influence the accuracy of the final part that are need to be determined. So we have enlisted these factors here. Okay. So let us come back to rapid prototyping. However, I might use the term rapid prototyping and additive manufacturing hand in hand. But when I say additive manufacturing, that would definitely mean that the whole manufacturing is being carried out by an additive process. When I say rapid prototyping here is the initial product. Let us put some light on the history. So how does rapid prototyping evolved? So this time rapid prototyping is utilized as a part of an assortment of enterprises to depict a process for quickly making a framework or part portrayal before conclusive discharge or commercialization. The underlying foundations of rapid prototyping can be followed by two specific zones, topography and photo sculpture. These two were used in early 19th century. Early 19th century. So what is topography? Topography is an arrangement of the features. Arrangement of the features of an area. So the arrangement of the features, then bringing all these arranged features together to have the final product. So a layer technique was proposed by Blanthur in 1890. So this was the first time the rapid prototyping basis came into existence. So a layered technique was proposed by Blanthur as a right on time as for making molds for geological relief maps. Both positive and negative 3D surfaces were to be gathered from a progression of wax plates, and they were cut along the geographical form lines. The wax plates, they were cut through to form the geographical form lines here. So this strategy was additionally advanced by certain other researchers. They portrayed a layer producing procedure to shape throwing molds. The layers of the molds were created from particles covered with photopolymer pitch. The photopolymer pitch was used. So gum was also used here, that was specifically cured utilizing light. Gum was cured using light. Certain other researchers used the same technique using the metallic plates. So idea came from here, but the metallic plates were then used to have a topography structure here. So these because these were metallic plates, a cutter was used to cut these into the shape. Then certain overlay procedures were introduced like blanking apparatus, press shaping devices, forming devices. So mechanical processes came into existence here. Mechanical manufacturing processes came into existence to produce these plates. So this is a kind of a laminated plate procedure. We will discuss the kinds of rapid prototyping processes in which we will see the powder process, laminated plate process and liquor process are the major classification of rapid prototyping. So this is a kind of a base for our laminated sheets or solid material rapid prototyping processes, which are even being used today. So next was photo sculpture. So this is a strategy that was proposed in again 19th century for making reproduction of 3D objects. The system includes shooting the question or shooting the, I would say, the subject or my product at the same time with 24 cameras which were similarly divided around a room. Then these were used to utilize the outline of each photo to cut 1/24 of a tube shaped part of the protest. So what happened, this tube is there, this is divided into 24 camera was used to produce the shape, and this is divided into 24 parts. Then endeavors were made by different designers to enhance a strategy by mitigating the manual cutting steps here. Now, further the researchers propose the utilization of organized lighting to make shape for a protest photographically, and after that utilizing these lines to cut and manufacture the form sheets. So, in 1950s, that is in the half of our 20th century, Munz developed a layer producing framework for creating the cross segments of an examined question by specifically uncovering a straightforward photograph emulsion. The framework creates here the layers by bringing down the cylinder into a chamber and including a proper measures for photograph emulsion and settling operator. So, you can read the work by Munz to have more information on the photo sculpture. So, this is of a figure that is taken from a reference here. So, this is a cylinder which is put into the chamber and the various lighting techniques were used to have the shape of this one. So, after 1950 here, now recent here in 1990s, and I would talk about the 20th century as well, 21st century as well here. Now, the huge increment in the quantity of the financially accessible rapid prototyping framework of the 1990s can be classified by progresses in 3D modeling, computer aided manufacturing and computer numerical control. These are the terms which we have been going through multiple times. So, this was all developed in 1990s. So, the yearly development in the sales of rapid prototyping process was about 40 to 50%, and in 1999 the deals development was 22%, and it was assessed that 3.4 million sections were assembled overall utilizing rapid prototyping innovations. Now, this fact was brought into light by Wohlers 2000. Wohlers in 2000. So, another vital angle is that the use of rapid prototyping has spread to different areas of economy. This solid and predictable development in the deals and boundless utilization of the innovation show exceptionally hopeful prospects for rapid prototyping business and its future here. So, we can see here the work of this man Wohlers. In 2000 he said that the rapid prototyping had these much of applications. So, maximum consumer products, or it has maximum application in consumer products, then medical and dental products, academic institutions also use that, and these were also the certain applications here. So, next I would like to discuss how rapid prototyping is an integral part of concurrent engineering. We know that concurrent engineering is designing and development when the various steps are working simultaneously rather than consecutively. Step by step procedure is not very prominent here. The various steps, various parts of the product development team all work together and all the processes are going simultaneously. Most of the processes are even overlapping. So, how rapid prototyping is an integral part of concurrent engineering. The principle of concurrent engineering is, that is, this innovation is behind it is 3D CAD demonstrating. The simultaneous in performing diverse plan and assembling exercises introduce a chance to pack the general item advancement time. Here by pack I means reduce. Also, it makes the potential outcomes to be innovative by giving more opportunity to the outline cycles here. Simultaneous engineering situations have developed extensively amid the last few a long time to incorporate 3D displaying. For 3D displaying, we have rapid prototyping. Now, 3D display turns into a focal part of the entire item or venture database, which implies that taking all the things together, that is planning, I would say plan, then development, then assembly. I consider development as my manufacturing as well. development and manufacturing, then assembling, then investigation. So these all things come together. So let me try to compare the general process with my concurrent engineering here. So in general process, what we have: conceptual design. What I will try to put here is how concurrent engineering is also known as time compression engineering. Time compression engineering, that is, the overall time is reduced. So in general we have concept design, then detail design, then engineering analysis, then prototyping, then tooling and production. So I have time going through here. This is our time. So these are various steps here. In a non-concurrent engineering way. So what happens in concurrent engineering? What do we have first here is 3D CAD modeling. In 3D CAD modeling, both these things, conceptual design and detailed design are working. However, this 3D CAD modeling can be used here as well. So when the conceptual design is there, when the conceptual design is complete, then detailed design starts. There is a little overlap here, because when even the concept is there in the mind of the designer, the details, some specifications are given, and when if the concept is very clear at this point of time, the concept is very clear, the detailed design takes a fast shoot and the detailed design is complete here. So this is my 3D CAD modeling here. Then is prototyping. Then what we have here is virtual reality and finite element analysis kind of a thing. So what we can put here is virtual prototyping. Virtual prototyping and engineering analysis. Virtual prototyping is using my CAD software only to do engineering analysis and having the prototype on the screen only here. So these things go hand in hand here. So at this point of time, we are even close to engineering analysis. Next comes the rapid prototyping here. Rapid prototyping. So we can see even in concurrent engineering, even there is an overlap of the various steps here, but till engineering analysis the time is almost same. But when we have rapid prototyping here, so this overlap, this prototyping has started even during this engineering analysis only. Prototyping starts here only. Right? Then after prototyping, because the initial prototype is ready here, tooling decisions can be made here. And if I talk about additive manufacturing here, the production can also be started here. The time to production. So in this case, the time to production was this much, and in this case the time to production is this much. So this difference here, this difference is my time compression. So that is why it is known as time compression engineering. So I could better put here, this is my time compression. So to put it into maybe 2 or 3 major steps, this is concurrent engineering, 3D CAD modeling, this is concurrent engineering, virtual reality, and this is concurrent engineering, rapid prototyping process. So even if additive manufacturing is not here, the time to production, that is to time to decide the final production, that whatever manufacturing process would be there, that is reduced here. So let me take this thing like here. So there is no duplication and no misconception in rapid prototyping. So the item data here can be duplicated and maybe reutilized. It is promptly accessible for various downstream applications. Gatherings can be checked for obstruction, and through virtual prototyping can be practiced through scope of assignments here. Different people can be assigned job here, so obstructions can be seen here only. Then auxiliary and warm examinations can be performed on similar models using CAE software, CAE applications, computer ready applications here. I would share here, this is my VR and CAE. CAE is actually computer aided engineering. These applications are also as recreating downstream producing forms, and at last these exceptionally precise also information rich models can be taken straight forward to the rapid prototyping and computer aided manufacturing applications, accelerating the process, arranging and now and again disposing of the requirement for illustrations. As an incentive comprehension of various geometrical portrayal methods and configurations for information trade, it is urgent for the effective usage of rapid prototyping innovation here. Innovation is induced here. So, I will take a break here and would come with the next part of this lecture. We will discuss various geometrical modeling techniques and we will go through the general procedure of rapid prototyping. Thank you.